Hello and welcome to yet another video of Cornerstones of Math, your quality math channel. As you can see, I am going to tackle some probability problems in some of my upcoming videos. I am not going to upload them one after another though. I will upload videos with other topics as well, so my next video is not about probability, and I think probability videos will appear like every 2 or 3 uploads. But for now, let us take a look at this problem. Consider an experiment of throwing a regular die n times, where n is of course a natural number. So here, we are going to obtain total n numbers, which I will call C1, C2, so on all the way up to Cn. Of course, they are one of 1, 2, 3, 4, 5, or 6. Then, let x be the product of all values obtained from this experiment. So using our notation here, we can write x as C1 times C2 times C3 times Cn. Problem A, what is the probability that x is divisible by 3? And problem B, what is the probability that x is divisible by 4? Alright, first, what is the number of all possible outcomes with these n trials? This is easy. The number of all possible cases is simply 6 to the power of n. Now let us take a look at the first problem. Probability that x is divisible by 3. Here, let A be the event that x is divisible by 3, which we can also write like this. In order for x to be divisible by 3, the multiples of 3, in this case 3 or 6, must appear at least once during n trials. Here, counting all possible cases where 3 or 6 appears at least once is definitely not simple. Therefore, we will consider the complement of the event A, where x is not divisible by 3. This complementary event is much easier to count because x is not divisible by 3 when all values from the experiment consist of either 1, 2, 4, or 5. You know, not 3 or 6. Therefore, the probability of a complement is given as these n numbers must come from these 4 numbers, so we have 4 to the power of n over the total number of cases is 6 to the power of n, so we have 2/3 to the power of n. Therefore, the probability of event A is given as simply 1 minus probability of a complement, which is 1 minus 2/3 to the power of n. And this is our answer. So here you can obtain this pro tip here. When you see the phrase at least once or something like that, you think of a complementary event. Alright, now let us move on to the next one. The probability that x is divisible by 4. Here, let's use B as the event that x is divisible by 4. Again, we will consider the complement of event B, where x is not divisible by 4. And now, there are 2 cases for that, because let's think about it. When is x not divisible by 4? The first case is when all values from the experiment consist of only odd numbers, 1, 3, and 5. So in every trial, one of these 3 numbers must appear, and there are total n trials, so there are total 3 to the power of n ways. So here's our number of cases for case 1. And the second case is either 2 or 6 is obtained from a single trial, and 1, 3, or 5 are obtained from other n-1 trials. Notice that these are even numbers containing only single 2 as its prime factors. We cannot have 4 here because then x becomes divisible by 4. So a single trial that is either 2 or 6, so there are 2 different possible values. Then there are n ways to place this particular trial in the whole experiment of n trials. Lastly, there are 3 to the power of n-1 ways for other n-1 trials that yield either 1, 3, or 5. Therefore, there are total 2 times n times 3 to the power of n-1 ways for this case. Therefore, from cases 1 and 2, the probability for B complement, where x is not divisible by 4, is given as, first, for case 1, we have 3 to the power of n ways. Then, for case 2, we have this number of cases. And of course, the number of all possible outcomes are 6 to the power of n. And here, let's write this part as 2/3 times n times 3 to the power of n. Then we can extract 3 to the n over 6 to the n, which is simply 1/2 to the power of n. And here we have 1 plus 2n over 3. Therefore, the probability for event B is 1 minus probability of B complement, which is 1 minus 1 plus 2n over 3 times 1/2 to the power of n. So we have our answer here, but let's take a look at one more thing. Their limits. Note that in the limit of n goes infinity, limit of probability PA is limit of this expression, and this one is easy because this 2/3 to the power of n simply goes to 0, so we have 1. And if you think about it, the probability approaching 1 makes sense because the more we throw the die, the higher the chance of getting 3 or 6, thus making the product x divisible by 3. Next, the limit of probability PB is the limit of this expression, and actually let's write this part as 1 plus 2n over 3 over 2 to the power of n. So we have a competition between this increasing polynomial in the numerator and this increasing exponential term in the denominator. I don't want to turn this video into a limit video, so I am not going to explain in detail, but the one important property of exponential functions is they always increase faster than every polynomial function. So no matter the degree of polynomial is, the exponential function eventually wins, so this term approaches 0. So we have 1. This means that the product x of obtained values will surely be divisible by 4 for the sufficiently large number of trials. This also makes sense since the more we throw, the higher the chance that 4 or 2 even numbers are obtained. Alright, so with this limit observation, we are surely done for today's video. Thank you all for watching. Please stay tuned for my upcoming videos from other topics as well, and I will see you in another video.